still 8.1. We have the Pythagorean theorem. We have the 45, 45, 90. And we have the 30, 60, 90, all in that one little section. So we'll finish off the section, and our quiz on Friday is just on 8.1. And we'll review it on Thursday. And if you want to come on Zoom tomorrow, I'll be on Zoom about 10 o'clock, if anybody has any questions. So we're going to start with drawing and the rules for 30, 60, 90. We're going to start by drawing an equilateral triangle. So what do we know about equilateral? What do we know? It's all, okay, all congruent sides. So what else do we know? Yeah, so they tell you it's equilateral. So, but we know from first semester, if we're equilateral, we are also equal angular, and if we're equilateral and equal angular, then we are regular. So I really think they should have just put regular down. So the tick marks for the equilateral are quite easy, but the equal angular means that each of these angles has to be the same. Now if there's 3 angles and they all have to be the same and they all add to 180, then each of them has to be 60. So I'm going to put 60 small in the corners. And then someone decided to draw an altitude. And from chapter 5, an altitude comes from the vertex, goes to the opposite side. And yes, sorta. He's just perpendicular, but then you are totally right. So that was fabulous. He comes to the side and he's just perpendicular to that side. But because he's in an equilateral triangle, the altitude gets an upgrade in name, and he ends up being a perpendicular bisector as well. So you're totally right. So he takes that 60 and he bisects that angle, because if you look at just the right side, you've got a 90 that's perpendicular from the altitude and the 60. So that the top has to be a 30 for 180 degrees in a triangle on the right-hand side. And then you'd have 30 on the other side as well. So if this side was x, and this side was x, and this side is x, what does the perpendicular bisector do to that side now as well? Cuts it in half, so this part would be 1/2 of whatever that side was to begin with. So what we're going to do is pull out this right triangle. Got a 60 and a 30. I'm going to label the top one A, the right one B, and the right angle C. And we need to do some labeling just like we did in 45, 45, 90. We have the hypotenuse, because it is a right triangle. And in the 45, 45, what were these two sides called? The legs. And in the 45, 45, it's so easy because they were congruent. So once you had one, you had the other. It was quite simple. But these are called legs, but they need some differences between them because they're not congruent, because it's not isosceles. So what they assume that you already know from past algebra and math classes is how to find who is the smallest side and who is the longest side. So I don't know if you know this or not, but if you have a 30-degree angle and a 60-degree angle, the side opposite the 30 will be shorter than the side opposite the 60, only because the 60 is bigger. So the side opposite the 60 will be longer. So then across from the 30, he will always be known as the short leg, or SL. And then across from the 60, he will be always known as the long leg, or the LL. So again, one more time, how do you know who's the short leg? It's the side across from the 30. and the long leg is going to be across from the 60. Now that doesn't mean the triangle will always look upright and always look like this. The 30 and the 60s can be in different positions. You just have to match it and go across, okay? We have two formulas. We have hypotenuse is equal to 2 times the short leg. And we have long leg equals radical 3 times the short leg. So we're in the 45-45, we only have one formula, but here we have two. Bless you. Now, if you look over here real quick, so you see how we have the 45-45 90, and then we have the 30-60, you don't know that one yet, the 30-60 90 formulas. This is my most common mistake, is that you're so used to doing the square root of 2 times the leg for the 45, that people add the square root symbol here for the hypotenuse, but don't add the square root. This is just a plain old 2. Now the reason why he's double is because you took half of him here. So if this is 5, this is going to be 10, because that altitude turned into a perpendicular bisector. You can divide it by 2. Isn't that nice? Yeah. Okay, so we're going to do three problems, and then see how, if you want some more or if you want some less, we'll just see how you do. Okay, so we're going to draw one at a time. Okay, so the first one, tilted on its side on purpose. And they only gave you one angle in the corner, 30 degrees. So what is our goal of this chapter again, is to find all 3 sides and all 3 angles. So we can easily know and find this angle, because 180 degrees in a triangle, this is going to be 60, because we already have a 90 and we have a 30. Okay, so I need to label the hypotenuse, the short leg, and the long leg. And I would label until you're comfortable with this after you do it. Well, it says you to form a habit, it's like 26 times, isn't it? So after you do a couple of these problems, then you can stop labeling. But for right now, do you agree? The side across from the right angle will always be the hypotenuse. Then I look for my 30, and I look for the side across from him, and the side across from him will be known as our, so I'm going to label it short leg. And then I look for my 60, and the side across from him is going to be our long leg. In the very beginning, I would start by writing both formulas down, and then see what we have. The only thing given to us in this problem so far is our long leg on our sides, because we have all the 3 angles. So if you look at the first formula, there's nowhere to put in the long leg. So you sort of have to ignore this one first, and then we'll go to our second one and then come back. So our long leg is 3, so we'll go ahead and put in 3 and bring everything else down. So the square root of 3 comes down and the short leg. Now this looks like last night's. What are you going to do to solve for the short leg this time? Divide by radical 3. So yesterday, what did we divide by? Yeah, so this time, just a radical 3. So I end up with 3 over radical 3, which is an illegal answer. So then rationalize it. Can you do it in your head now? 3 radical 3 over, yep, you should be able to rationalize in your head. And then what happens to the 2 3's? These 2, yep. And so my short leg ends up being radical 3. Okay, so now that we have the short leg, I can go and put it into my hypotenuse formula, and it's 2 times radical 3. Well, an outside and an inside don't combine at all. They just sort of attach next to each other. And so what's my hypotenuse? 2 radical 3. Nice job. How's your first one for 30, 60, 90? I don't think they're that bad, are they? Okay. Ready to go again? I'm going to move the 3. Where was the 3 this time? Long leg. Okay, now let's move him. I think I'm going to put him in short leg next. Okay, so they're missing that 60 at the top, but easily put in because we know we have already a 90 and a 30 to add to the 120, so we need 60 more for the 180. I'm going to go ahead and label. Who is the bottom, everybody? The bottom down here. Long leg, excellent. And then across from the 30 would be the short leg, and I said I was going to give you short leg. And then this guy pour over here is the hypotenuse. So I start, like I said, the very beginning, I write both formulas down. And we take a look at what we have. Now, the book gives us the short leg. So in this case, I could put the short leg in here, or I could put the short leg in here, and it doesn't matter what formula I start with. Versus over there, I didn't have a choice because I was given the long leg. I could never start with this formula. Agree? So if I put it in here, this is lovely. You just get a hypotenuse that is 6. Absolutely. And then if I put the short leg in here, 3 and a radical 3 just sort of combine because one's in and out, and you simply get 3 radical 3. My favorite is when they give you the short leg. Okay, where else could I put the 3? Long leg, short leg, one more. Hypotenuse. Let's do one more. Put the 3 in the hypotenuse. I'm going to label H for hypotenuse. Can anybody tell me on the left-hand side, what side is he? Long leg, very good. And then across from the 30 on the bottom, everybody, is short leg. I start by writing the 2 formulas. And so now I have the hypotenuse. That's the only thing that the book has given us. So can I start by plugging any values into this equation? And you can't do it. So you have to start with this one versus the other one. We had to start with the other one. So I'm going to put a 3 in. And you simply are going to divide by 2. Don't put in radical 2. You're just going to simply divide by 2. And the short leg. And we're going to leave everything in here in fraction form, no decimals. So we're going to leave it 3/2. And we're going to leave it improper. We'll never leave it mixed. We won't do 1 1/2. So we've got a short leg of 3/2. Then on the unfortunate part for those, if you get your short leg wrong, look at where you're putting it. You're putting it into the long leg, so you're going to get the long leg wrong, right? So pay attention and just be careful with your fractions. Last one. What happens? What happens when you take a fraction times a radical? Just think about this over 1. What do you get in the bottom? 2. And then what do you get in the top? You got it. So 3 radical 3 all over 2. And the only thing we could do is divide these 2, the outside and the denominator, but unfortunately they don't divide. Okay, so practice the 30, 60, 90. Sound like a plan? Okay, it's on Google Classroom. And we're going to do the evens again. We're going to start with number 4, though, because I just did 1, 2, and 3. So start with number what? 4, yes. You want to move and work? Okay. Evens only.